So here we go, guys. This is my first time trying to use this, but the goal is to learn about implicit differentiation. So implicit differentiation. The big idea is you guys have actually already been doing this. When I've asked you to take the derivative of an equation and find the derivative of it, dx of this whole thing. What you've been doing is writing something like y prime equals 6x plus 2, and that's all you've been writing. But what we're really doing, and we write y prime, but we can also look at this, and although this isn't a fraction, we can think about dx as kind of like we're multiplying. It's not multiplying. But dy dx is what we could write, and that is something that we have done. So you can kind of think of it as d dx times y. It becomes dy dx, which means the derivative. And we can also think about the derivative of like 3x squared, and we can follow chain rule. So it's really the derivative of the outside, 6x, right? 2 times 3 is 6, then the x to the 1, times the derivative of the inside. Well, the derivative of the inside is going to be this x times the d dx. We're going to get dx plus 2, and then we could think about chain rule again and go, okay, 2x to the 0, I'll just write it out, 2x to the 0 times, again, the derivative of the inside, dx. And then what dy dx means is how y changes with respect to x. So we've shorthanded this to y prime, but again, it can just be dy dx, and that's fine. And then we look at dx and go, well, how is x changing with respect to x? Well, they change exactly the same because they are the same. So dx is just 1. So we very quickly end up with what we had before, which was just 6x plus 2, and we've been just ignoring the dx. Okay, so that's the quick idea. So I'm going to kind of put that off to the side, and now we're going to do this with something harder, but I hope you find that it's super easy. We are going to take the derivative dx of something like x squared plus y squared equals r squared, which is the equation of a circle. So it doesn't really matter why we're doing it, but this is what we're going to do. So we're taking the derivative of x squared. So that's going to be 2x. And I'm going to write dx just so we get in the habit of it, not because we need it, plus the derivative of y squared. Well, that's going to be 2 times y times the derivative of y with respect to x. Well, the derivative of y with respect to x is dy dx, which is what we were writing over here, right? Maybe I should change my colors. It's what we wrote over here. So it's the same thing. We just have to use chain rule to get to it. Equals 2r times the derivative of r, which is dr dx. So that is, oops, there we go. So that's the big idea there, dr dx. So let's try this again, but let's make it a little bit more complicated. We're going to do, let's do something with some parts to it. We're going to take the derivative with respect to x of sine of xy plus x squared y cubed equals, we don't even have to have it equals anything, but let's do something weird like pi. So here looks like a very complicated equation. That's not too bad. So we are going to deal just like all of our rules. We got to start from the outside in. The derivative of sine is cosine. We leave everything in the middle the same, xy, times the derivative of the inside. And the derivative of the inside, we need to follow product rule. The derivative of x is 1 dx dx. I don't need to write it, but I'm going to put my 1 times y, it's derivative of the first times the second, plus the derivative of the second. The derivative of y is dy dx times the first. So that's my chain rule of the inside. Plus, so I'm done with the derivative of the sine part. So now I'm dealing with the x squared y cubed, plus the derivative of the first is 2x times dx dx, but I'm not going to write it. Leave y cubed the same, plus the derivative of the second, which is 3y squared dy dx, because I got to do the derivative of y, times the first, x cubed. And then I'm going to say, now I'm done with that derivative, and then equals, and the derivative of pi, well, we know the derivative of a constant is 0, so that's that. Those dots that you're seeing when it comes up like that, I think, although, I don't know, I think I can make it graph it or something, but anyway, that's the big idea. I hope that you're able to get this video and watch it, and we're going to practice this in class. Thanks. Bye.